among us today, and I want to make sure that they are thanked appropriately. But let me just start off by welcoming all of you that are with us today. Certainly Mr. Sinha and Mr. Gandhi, it is a pleasure to have you with us, Mr. Bali, and of course our friends at Greening the Grid, who have worked so hard on so much of this. But let me get into the substance of my comments quickly so that we can move on to the real work at hand. In addition to being fascinated by the technologies that we're all now becoming very familiar with and almost becoming habit forming over these last several weeks because of the current situation, and I certainly hope that all of you are safe and healthy and enjoying some sort of peace amidst all of the chaos. One of the great sort of fantastic outcomes of this is that the technologies have now become all sort of almost instinctual for us. Monali and I were just talking for a couple seconds before we came online about the fact that I actually had not used Zoom before today. But, you know, reading the instructions, looking at it quickly for about 15 seconds, I realized, oh, it's a very similar platform to the others. And so I could get on, even though my experiences have been with the Google and with the Microsoft. And now here I am with Zoom. So now I feel like I'm fully equipped with all the modern technologies to live the life we're now living. We hope to get it over with soon and move on to life in a different way, but we've adapted very well. And that ability to adapt is key in the personality of the human animal. And the simple fact is that while it's my pleasure to welcome you today to this webinar, I think what is to look at the low load operation protocols for flexible operation of coal-based power plants here in India, it is no more appropriate at any place in the world that we should be doing this than in India. The importance of this strategy for India, which already has incredibly high aspirations of integrating large amounts of renewable energy into the grid. And while I quote certain numbers, you know, I'm always a little bit afraid to quote those numbers because I know India is so forward leaning on this that they change regularly. But the 175 gigawatts of renewable energy has limited balancing resources. And we are looking at a way to make those balancing resources more effective and more efficient. As you know, I don't need to tell this gathering of folks, the world is steadfastly moving toward a future that is energized by renewables. And India is certainly leading in that race. It's phenomenal to me, and it's an exciting time to be in India because of the leadership and because of the forward-leaning strategies that are put forward by our friends here, like in the recent auction conducted by the National Hydropower Corporation for 2 gigawatts of solar capacity. The tariff bids were 4.7% lower than the 2019 averages. This clearly shows that the investors have faith in India's vision, and it builds a pathway for India to continue to move forward in this in a very aggressive manner, because India sees the future, and the future, as they say, is now. I happen to work for the US government, as you all know, and I'm incredibly happy that the US government's able to contribute to this agenda through the bilateral program with the Ministry of Power that we call Greening the Grid, or G2G, implemented by our partners at Deloitte. And the program supports the government of India's efforts to deploy that 175 gigawatts by 2022 by managing issues arising out of large-scale integration of renewables into the Indian power grid. We all know, and I'm talking to a room full of the converted, but we all know that in fact, this is not an easy task. The technologies that are required, the management skills that are required, the understanding of the science behind this that causes power plants to heat up and cool down, and the consequences of that scaling, moving up and moving down the heat scale is incredibly sensitive, and our ability to respond to that is going to make it viable for us to integrate these 175 or 240 or perhaps even more in coming years of renewable energy. One of the key pilots under the GTG-RISE initiative is flexible coal-based power generation, wherein a few pilots that have been implemented to support development and execution of a nationwide roadmap are in the offing. And to execute these pilots, AID has partnered with India's largest public sector power generation utility, NTPC Ltd. and with the state level utility of Gujarat, or the GSECL. As a part of the pilot and the technical preparedness and the cost implications of flexible operations, all these were studied at selected units. And I've been able to watch this over the last several years happen piece by piece unfold. They've helped us develop a fleet-wide strategy and a business case for not only policy, but the regulatory changes for incentivizing flexible operations, those that are absolutely necessary to make this happen. Over the past 3 years, GTG-RISE, we're happy to say, has carried out a series of the technical feasibility studies for both the utilities and has conducted multiple operator trainings. I've been a part of several of those, and they're exciting to see. And the capacity building workshops are a piece, we believe, that are helping the various countries in the region, and certainly the folks here in India, prepare for that future that it's right on its way. The pilot journey continues with low load test runs conducted at select units, and this provides evidence and the basis for a nationwide scale-up of flexible operations. In May of 2019, NTPC successfully completed its second trial run at the 40% minimum load of the 500 megawatt capacity unit at its Mauda station. These tests were conducted based on low load flexible operations procedures developed and guided by GTG-RISE experts and the Bharat Heavy Electricals Limited, BHEL. So you can see there's a lot of players in this. This is not one easy thing where we're simply teaching or supporting a linear approach to evolution of a technology or of a strategy of doing things. There are a lot of players, there are a lot of testing, a lot of pilots, and there is a lot of information to be not only gathered in the first time around, but also to be ground truth as we move forward. Similarly, in Gujarat, as I'm sure you know, we also successfully conducted low load test runs at a 40% minimum load at its units with help from USAID's GTG-RISE project. Recently, USAID has extended its support to the Karnataka Power Corporation Limited, KPCL, to make its coal plant more flexible. And that is meeting with incredible success. The webinar that we're all participating in today is really aimed at creating awareness amongst relevant stakeholders by providing access to the firsthand experience of conducting these low load test runs at various coal-fired powered plants and units of the NTPC and the GSECL. We're also releasing a report, the minimum load ramp test procedures, which we hope would serve as the guiding tool for other utilities who would be interested in undertaking low load test runs. We've seen this happen before. Many of the pilots that we've worked on, many of the testings that we've done, a lot of the capacity and skills that we've developed have been ground truth. They've been proven to be fruitful. And then in the end, we see them being picked up by other entities, sister generators in neighboring states, and sometimes even in other countries. So we're very interested in seeing this not as a solution to any one given place, but as a pilot that will allow us to extrapolate this out to other geographies and other power generation systems. Before concluding, let me acknowledge just a couple key long-term partners. Certainly, the biggest one for us that is incredibly important to acknowledge today are the folks at NTPC. And those of you who know Mr. Tiwari know that he has been a champion of this issue for long enough now to really be, in many ways, to be the patron of a lot of this testing that's going on. Mr. Tiwari, we want to thank you for taking the time to join us today, as well as for your active participation and support of the G2G program. We've been fortunate to have partnered with NTPC, not only for this initiative, but also in the past for the GEP, the Greenhouse Pollution Prevention Program, under which the CENPEP was established. I also want to thank, very quickly, take the opportunity to thank Mr. Gandhi for his participation with the GTG program and making the joint effort possible. He's really been a champion and a big driver of this work. And of course, one more time, because I can never say thank you enough, our trusted friends at Deloitte LLP. We want to congratulate them, our implementing partner of the G2G-RISE program, for organizing this webinar, and thank all of you for joining us today. But make sure that you know that this is one step along a long journey, and the journey has been incredibly fruitful. It's certainly been mired with some challenges, and a little bit of failure. But nobody's ever moved forward in any way throughout the world without taking a couple steps back along the way. We feel that the couple steps back that we've experienced in this particular study and the webinar discussions we'll have today are indicative of the fact that we have made every one of those backward steps incredibly productive and incredibly fruitful. And they've engineered an opportunity for us to move forward and build successes based on the challenges that we have experienced along the way. So let me stop there and thank all of you at one last time for this opportunity to continue to learn, and also for your participation today as a part of this session, and also as a part of the larger effort to advance India's sustainable and productive energy and power sector programs. With that, I say thank you, and I'll turn it back over to my colleague Monali, and I'll sit back and enjoy the proceedings. Thank you.
Thank you, Michael. Thank you so much for your remarks. Mr. Tiwari, I think, has been caught up in a meeting. Mr. Prakash Tiwari, Director of Operation at NTPC. So what we are going to do is go ahead with the presentations, and whenever he comes in, we'll just ask him to, present. So I now will request my colleague Anuj Vashisht from GTG-RISE team, implemented by Deloitte, to set a context for this webinar. So over to you, Anuj.
Thanks, Monali, and thank you, Michael, for those encouraging words. Good evening, everyone, those who have joined the webinar on the low-load test runs. Before starting the presentation by Mr. A.K. Sinha, I would like to give you a brief background on what kind of activities and tasks and challenges we encountered over the last 3 years in this pilot with NTPC and GSECL. We started on the pilot long back in 2017. The scope of the pilot was essentially to look at the techno-economic feasibility of a couple of units at NTPC as well as GSECL. We identified a 500 megawatt unit at Jhajjar and a 200 megawatt unit at Ramagundam for NTPC, as well as a 200 and a 500 megawatt unit at the Gujarat State Electricity Corporation, that's GSECL. And the objective was to look at how these units have been run over the last 10 years, what has been the damage that has been inflicted because of the operational procedures that were being taken up by the teams. And going forward, if these units, typically 200 and 500 megawatt subcritical units, if these are subjected to flexible operations, what is the kind of damage that is foreseen? What are the costs associated with those damages? And how, in a regulatory environment, how we can address those costs for the utilities. So that, in a nutshell, was the overall objective. And then, of course, coming back to, once we find out the recommendations, we had to support NTPC and GSECL, which we have wholeheartedly done with fantastic support from both the utilities over the last 3 years. This webinar, in fact, happens to be the third webinar in the series of this pilot. And as I mentioned, that the outcomes were primarily related to what kind of operational changes would you foresee in running the units during flexible operations, because that's something which the Indian coal-based units had not been subjected to so far. And going forward in the near future, when you have a large ingress of RE capacity into the grid, the coal-based units would be required to flex up and down, maybe do a toe shifting also during a week. So that's where we looked at the kind of procedures that would be required to be changed. And this is one of the report release that Michael mentioned we plan to do today. Also looking at the efficiency of the efficiency parameters of the plant, including part load efficiencies. We also looked at what kind of incremental cost would a generating unit of a 200 megawatt and a 500 megawatt unit would typically incur. And of course, on the regulatory and policy advocacy, because essentially the Indian Electricity Grid Code regulations provided compensation for 55% PLF, plant load factor. And we are looking at scenarios where the plants would be subjected to run below 55%, and how those costs would be attributable and would be recovered by those utilities is a major concern for the Indian power plants. So we started off in 2017, and we identified those units. We were supported on the technical front by one of the I should say one of the best technical partners on flexible operations, Intertech. I'm pretty sure that Nikhil has joined this webinar, and the deep dive technical feasibility assessments were essentially carried out by Intertech on this engagement. And we looked at how these operations have been carried out on these 4 units over the last 10 years. The data was analyzed, and then we identified where exactly what went wrong. And this, I should pause here to say that this essentially was carried out considering the Indian coal conditions and the plant dispatch schedules that the units were subjected to. So going forward, once we had the damage cost modeling studies inbuilt into our entire overall framework, we identified the kind of costs that were attributable to such operations, and in the near future, what essential retrofits with minimal cost implications should be allowed or should be considered by those units if these are subjected to flexible operations. This also involved, training and capacity building of a number of operators, a number of engineers, and we did a good number of workshops in the last 2 to 3 years. We also looked at how this pilot exercise of 200 and 500 megawatt units can actually be rolled over and scaled up to a fleet-wide level for NTPC and Gujarat. And we are also now looking at scaling it up for other state utilities. So that is in a nutshell what the pilot is all about. We are in the final year of operations, and we are looking forward to contribute more to these utilities. Test runs happens to be one of the key areas where we think that the Indian plant operators require the confidence building measure, where our studies that we have carried out on GTG-RISE would certainly contribute, maybe to a large extent. And for that reason, that very basis in mind, we developed the test run procedures, and we have the upcoming presentation from Mr. Sinha on what kind of precautions need to be taken while preparing the test, while preparing for the low load test, and how should the units look at the efficiency parameters, what kind of damages can be inflicted if those are not run properly. So I would now request once again to Mr. B.A. Gandhi. He is from GSECL. We recently conducted a successful low load test run at 40% at one of the 500 megawatt units at GSECL. And I would request him if he can share his experience on this particular event.
Okay, thank you, Anuj. And respected dignitaries from various esteemed organizations, USAID, NTPC, Deloitte. On behalf of GCCL, I'll welcome all of you, actually, sir. Again, I think Anuj has already mentioned that this trial was, I think it was a 3-year journey. We have started during February 17, and I think then this MOU was signed, and we have shared, I think, 10 years database with USAID as well as Deloitte team. Actually, I think that was analyzed by Intertech team, and Mr. Doug and one more senior person was there actually who analyzed all these things. Actually. But initially, see, what was the issue with us actually? We are not confident how to run these units at low load actually. Our technical minimums are almost above 70% for all of our units actually. And normally SLDC or load operator dispatcher, they also don't advise us to go below this actually. So again, this was, I think, a very, we can say actually we have not carried out such test in our routine operation actually. And now for last 2-3 years, we have seen so many changes in the grid operation also actually. We are facing so many difficulties because of this highly erratic tendency of wind. And I think for just for this year, I can share you some information about grid. Gujarat grid, the total capacity is around 28,278 megawatt as on March 20. And RE consists of 31% in terms of capacity. In terms of energy, it is around 13%. Maximum wind variation, maximum wind in a day, it was around 4,752 megawatt this year. And maximum variation in one day of wind, it was 3,917 megawatts. So I think there is huge variation in wind in a single day actually we are facing. Also, the wind variation, I think for last year, it was for 174 days, it was more than 1,500 megawatt in a single day. And also again, see, demand fluctuation is also very high in our state actually. We have seen maximum demand variation in a day of around 5,200 megawatt actually. So all this imposes a challenge on our operation of our units actually. We have to frequently start-stop because there is it is very difficult for us to go beyond this our 70% technical minimum level. So immediately we stop our units again. After 2-3 days back, again we take the units. So for this year, I can share some more information about starts of our unit. Our coal-based units actually last year, 18-19, the number of starts due to low demand or this wind variation was 132 numbers. This year it has escalated to 2,000, more than 2,050. So this was a very good exercise for us to avoid the start stop. We can bring down our load to some reasonable level in consideration with load dispatcher, and we can avoid this start stop actually. And I think after sharing this data with Intertech team and Deloitte team, they analyzed all this our operational issues, and that the team has visited Ukai. I think in August 18 they have visited, and they have conducted a series of meetings with all of our departments actually, operation department, chemistry, maintenance, finance, everything, and they have made them aware regarding how we can move forward for conducting this test and what will the benefits of this test actually. So I think so many issues, technical issues, they have resolved with the Intertech team, and again they have supported us that you move forward and you just take a trial actually. So I think there were so many issues. I think superheater temperature control, which was the issue. Again, some of the loops were not in service. They have identified that this should be in service. So many guidance, I think guidelines they have given, and we have rectified all our defects. And I think in February 19, we have conducted low load operation with our own team actually. I think in February 19, we were able to run our 500 megawatt unit Ukai at 275 megawatt. That is around 55% successfully for more than 8 to 10 hours actually. Again, what we have done, we have shared our observations with the Deloitte team. Again, they've forwarded us some recommendation that you can change this parameter to this, you can change this mill to this. And again, all with their support, we were able to conduct this trial frequently up to 275 megawatt. And now I think meantime, the BHL, the OEM, he was also associated for this trial. And we have successfully conducted the low load trial in March, 55% and 40% load with 1% and 3% RAM rate. The trial was, we can say majority it was successful, but some few issues were there, which BHL team and the Deloitte people, they are in process of resolving these issues actually. Some of the parameters, I think, while ramp for 3% ramp up, we have observed the rates of around 1.8 to 2.4% only. So I think this need to be tuned. Our DCS CMC system need to be tuned to get this 3% rate in actual. Similarly, for 1% ramp rate, we were actually we have achieved 0.9 to 0.95%. It is almost, I think, we have achieved. Again, there were some issues regarding superheater temperature control. While ramping down, it was very difficult for us to maintain the temperature, superheater temperatures. Again, with the BHL team, I think for more than 10 to 12 officers or engineers from the BHL, they were at Ukai during this trial. They have tuned all the parameters of this turbine, boiler, C&I, everything they have tuned actually. Again, we have taken this exercise, this trial. And that time we were able to manage this trial with very smooth. But again, one issue, this superior temperature control, it was only persisting there. The other issues were resolved actually. The trial was very smooth. Meantime, BHL, they have supported us by installing edX software. I think they are in the process of developing this software. After installation of this edX software, again we have taken this trial up to 40% and 55%. And the trial was very smooth with the CMC on condition. We were able to conduct this, we were able to reduce the load up to 40% and 55% very smoothly. 2 or 3 issues, again, there are issues. We have observed a superior temperature excursion on higher side and reheater temperatures on lower side actually. So these issues, again, BHL, they are analyzing this issue and they will suggest us. And I think more tuning of this auto control loop still is required. Otherwise, I think the trial was almost successful, we can say, and we are confident. All this exercise, it has developed a lot of confidence in our people that we can run this unit without oil support up to 40% and 55% loads. And one more thing, actually, see, Deloitte team, they have also made a presentation to our regulatory officers regarding this, how this damage, what is the damage these people, these machines they are incurring on account of these fluctuations, and what should be compensation, what should be the compensation. It was also a good presentation, and regulator, he was also agreed that they will consider this compensatory mechanism in the ensuing our multi-year tariff petitions. So this was also a very good support from their team, so that we can quantify the losses and what were the losses and how we can get the compensation. Because see, even quantification was not, we are not aware of the quantification, how much losses we are incurring while load following or start stop, and all from support of USAID, Deloitte and this Intertech team, we were able to quantify these losses, and we were able to put up this to our management also, that we are incurring so much losses in this process and we have to avoid this. So again, this was a very successful exercise for us. We have developed a lot of confidence and awareness among our people. And once again, I thank you, all of these people who are associated with those who have guided us in this exercise actually. Thank you.
Thank you so much, Mr. Gandhi. It's really great to hear the experiences which Gujarat utility had in partnering with USAID and us for this particular pilot. We had also Mr. Prakash Tiwari, Director Operation NTPC, who was supposed to join us but has not been able to because of an ongoing meeting at NTPC. We will request him to say a few words whenever he comes online. So we would, before that,
Mr. Banerjee is there, I think. He would like to speak.
We also have scheduled Mr. Banerjee's discussion subsequently also.
Yeah.
Okay. So if we can then go ahead and release the report, and I will just ask my colleagues, Ripu, if we can have the report up on the slide. Yeah, thank you. So if we can also have Michael. I mean, this is the virtual report release which we have to, but yeah. We will be posting the, the PDF of the report on.
Is Michael there? Can Michael be there or?
I am here.
All right, Michael. So this is for you.
We are virtually doing a report launch. Yeah. So.
Thank you very much. Nicely done. Minimum load ramp test procedure for coal-based thermal power plants. Excellent. Congratulations to everybody involved.
Thank you, Michael.
Yeah, thank you so much, Michael. And now what we will do is go ahead with the technical presentation. I will introduce Mr. Sinha. I'm sure most of you know him. He's one of the pioneers in the field of flexible operation of coal-based power plants in India. He has been working with NTPC for a very long time, and now he is working with us at GTG-RISE as a part of the Deloitte team. So we are extremely fortunate to have him share the experiences from the pilots, as well as he brings in a lot of experience from the NTPC's work. So I will pass it on to Mr. Sinha for taking it forward.
Yeah, thank you, Monali, and thank you, Mr. Michael, colleagues from GTG, all the participants, Mr. Banerjee from NTPC, Mr. Gandhi, and all the colleagues from GSCCL, from NTPC, I think from Adani, Mr. Nikhil from Intertech, he's also there, I can see him. So good evening, everybody. Let me upload the presentation.
Sharing this presentation, I would like to just inform that the PDF, the report which has been released, has already been put on the GTG-RISE website, and the link will also be shared, subsequent to all these members who have attended today.
Okay, can you all see my presentation?
Yes, sir.
Okay.
Yes, sir, we can.
Okay, these are the things that I'll cover. Why do we really need a test run? Because there are a lot of questions. I could see that even before the webinar, I received a lot of questions from I think 4 or 5 different people. And I have tried to answer all these, and whatever will be left, we'll answer that in subsequent. I will send it personally. And let me start my presentation by throwing a few questions. Like, why do we really need a test run? And in fact, many of these will be an answer to itself. This questions in itself will be an answer to many of your queries. And if you reflect upon these, and whatever is left will answer that when I walk you through the presentations in the subsequent slides. So first is what happened during the 9 p.m. on 5th April. It's widely being acclaimed as a very successful grid management, but from the perspectives of the coal plant generator, you really need to think hard. And if at all you want to be relevant, you have to introspect, because see, that was an opportunity for you, a God sent, I'll say rather, a God sent mock drill opportunity on which we have not been successful. Because I'll tell you how. Because everything was managed by hydro, even curtailment, which is not a normal thing, curtailment of wind. So it's high time for the coal units to act now. And you have to prove the reasons for your existence for playing a greener role. So these are some of the questions asked by the participants. One is, what is the future of coal-based thermal power plants? See, everybody is questioning coal. So I'll explain what is the relevance and why do we need coal. For the coal generators also, they have to again explain, and they have to understand the relevance and what are the new roles that they have to play in the future. And there are other questions, I think it's more specific to the stations. Many of these answers, I have it in my slides, and some I'll answer later on, because in one session, I may not be able to answer all these because they constitute a lot of other things. So the first thing is, like, I've taken a slide, a scheduling effect of running an ISGS station. This is one example of one day of 20th April, 2020. So see the way the units are being scheduled and the way it is being run. This is the this is by the economic dispatch SCED mechanism. So I question, like, is it really an economic dispatch as claimed by many? See what is happening here. There are different cycles, more than 13. I think if you count, it's 15 to 16 different cycles of load following. But I'll consider only the significant load followings. First, here there was a 30% download, 15%. Here also it was very high, and then to a minimum load, almost to a minimum load. Stayed on for quite a long time. Here 43% down, and at 2% ramp rate. Again, we increased it for a very short time, and then again it was decreased. So this is the way how you are being scheduled. So there are certain questions. I see there's a cost to it. There are a lot of damages that is happening in your machine. And if you see in terms of cost, like every significant load following means when the load size is around 15 to 20% and at a very fast ramp rate. So the cost is more than 2 lakhs. I'm taking the lowest number. This is based on the studies that we did with Intertech. So you count the total cost. You can easily multiply it by at least 7. 2 lakhs into 7. This is the cost that has been incurred to the generators. And who is going to bear that cost? So now there's a question like, would the dispatcher schedule this the same way if this cost were known to him and if they had to provide the cost to the generators? The answer is clearly no, because then this no longer would be a security constrained economic dispatch. But there is a clear misalignment in the understanding of the generators, of the dispatchers and the regulators. The generators, they have to understand for themselves, because if they are not clear, then nobody else can be clear. They have to educate the generator, the dispatchers, the regulators. Again, they need to understand they are operating in a market. So the regulators and the grid operators, they need to educate the generators. So it's all of a management by the stakeholders of the power sector. There are some other important issues that we need to consider. One is the O&M cost under recovery. So everywhere some state GENCOs and many stations, even ISGS, they are approaching us, because in the past few years, there have been a huge under recovery of O&M cost. O&M cost has shot up like anything. And they are not understanding the reasons for that. So we are supporting, like Karnataka is one, Gujarat is one, many other state GENCOs are there. And there would be a need for investment in this retrofit. So how much really do you need to invest? And would you invest in all the units? And last but not the least is the safety issues. This has to be taken care of, because there can be a very serious repercussions of operating the units without proper awareness. Again, but still all having said all this, I just question, is it better than running this plant in this mode than shutting down the unit and starting up again? This too in a repeated manner. We'll find answers to that. So this is popularly known as the Indian duck curve. And when we see in the duck curve, this is the demand. I think this is a very well-known curve and all of you must be aware of this. So this is for one particular day of 2022. We are taking the worst scenario with the addition of 175 gigawatt of RE. And previously what I had shown in the dispatch, that dispatch was due to SCED. Not all the stations are operating in that way, but the mid-merit stations are operating that way. So typically on that day, if you see, this would be the way the coal units would be required to operate. In the morning, 104 or 106 gigawatt. Again, in the afternoon, it would be 33 to 34 gigawatt. Evening, 118 gigawatt. So most of these would be delivered by coal, because we still don't have enough of hydro capacity. See, normal time, like on 9 p.m., 9 minutes duration, it was a prepared sort of thing. So all the hydro stations were made to run. Coal stations generation was reduced beforehand. So that was not really a mock drill. But in the normal circumstances, hydro may not be on bar. Again, there may be some spillage problem. Gas won't be available for meeting this. So that remains with coal to manage the grid in those situations. Even in the coal, those stations who are lower in the merit order, they would still run on base load. But mid-merit, they would require to operate on, say, low load. And provided they are able to operate on low load at a lower load, 40%, 55% at least, and better if they can operate on 40%. Otherwise, they'll be asked to shut down and start again. And that is the worst thing that can happen to a coal generator in the market, especially in the market where you don't have compensation for your O&M cost, for the damages that is being incurred to the machines on account of your cyclic operation. Now, like for the coal stations, you need to understand that you sustain and you are relevant because of your cost. Still, coal is the cheapest source. The next slide will explain this very well. So this is the different way. There are the different ways how this balancing power can be provided to the grid. And everything will depend on the cost, on the economics. So last year, you remember, last month, I think it was the end of February, there was an auction of SECI in which RE plus storage was offered in two-part tariff. One was peak and off-peak. So for the lowest tariff was 2.88 with storage. So now coal has to compete with 2.88. And coal means the marginal cost of production from coal units. So presently we have prepared this based on the present price, but this will change very rapidly. See, there are many options in which grid balancing can be done, from the system operation perspective, from the market, from the load. Worst thing in the load is load shedding, which has been widely done in the past. From the flexible generation point of view, hydro is the cheapest. There's no doubt about it, followed by gas ramping. But unfortunately in India, we have very limited capacity, capacity of gas. So most of the thing has to be done with coal. And if something becomes cheaper than this, then coal won't get dispatched. So still battery is somewhere here. This is in terms of cost. Pump hydro storage, this is coming down, and along with different market models. Like this is 2.8, it also is with pumped hydro storage. There can be many other things. So if this cost comes lower than coal ramping, then those, just imagine what will happen to the low merit order plants. They'll be on permanent shutdown mode. They won't get scheduled at all. So everything will be market based, and now you need to think in terms of your cost, in terms of managing your damages, how you provide the value of flexibilization at the least cost. So before we run through the procedures, I'd like to explain to you some realities of cyclic operation. First thing is flexible operation is a difficult mode of operation. It's not easy, otherwise we wouldn't have assembled here and then lot of talks, lot of things happening, because it's a migration from base load to cycling. All the operators, all the plant O&M staff, they had been trained for the base load in the past. But now things are changing so rapidly. Now you need to change yourself, you need to change the entire range of operating procedures, the way you operate in the market, your financial models, everything is going to change the ground. And in fact, it has changed. But in fact, every unit can be cycled, and it can be operated with a minimum impact with certain interventions. You need some retrofits, you need some changes in the procedure, training. But see, first thing is the awareness must be there, and flexing with lack of awareness can be disastrous. This is what is happening in many of the stations, and we had seen in some stations, like there was a complete collapse of the bottom ash in one of the stations we had visited. There was an explosion in the bottom ash area, then there are a lot of damages. In fact, I had a lot of these pictures, but I haven't put it here, but later on I can share with you. Damages in the boilers, boiler tubes. It's almost every plant, every component of the plant is affected by cycling. except that somewhere it's more in the boiler, some components in the pressure parts. So, and another part is these damages are not immediate. They get accumulated over a period of time. And by the time you realize that something has happened, and by the time there are first symptoms which are visible, then it may be very late to correct, and it may be very costly to correct. You may need to replace your major component, some capital replacement. So this is another famous, everybody uses this curve to explain the mode of operation and the damages and the cost. This is from Intertech, but I've added the cost component to it. You need to understand this very well. See, this is the different mode of cyclic operation. One is load following. LL1 means mild load following, moderate LL2, and significant load following is LL3. So we are not concerned much with mild load following. What we are talking about is the significant load following. The cost of one significant load following is around, say, for different sizes of unit, I'm talking about 500 megawatt. It varies from, say, 1.95, roughly 2 lakhs. This is what I had shown you in the previous slide. Next is the hot start. Damages is more than the load following. Here the cost is 20 to 38 lakhs. See, the cost is not fixed. It depends on the unit. It depends on how you operate the unit. For example, one operate, he can cause, say, around 15 times to 20 times more damages than the other. And a very good operator, very good operating practices, some good automation in the plant can minimize your damage. So this is a range of cost that I'm showing. Next is the warm start. So here it is 28 to 51 lakhs, more than this. And the costliest thing is your cold start, which is to be avoided. So it is 42 to 91 lakhs. This is for one event. One stop and then start the unit, one complete cycle of start, stop. So you need to understand the limitation of your unit, and given the choice, so it is always better to prepare yourself for this mode of operation. That is why we are sharing with you the procedures for low load and what should be done for the low load operation. So while analyzing different interventions, there are various options if you compare in terms of cost, which you can do to prepare your units for flexibilization. So I'll show you this cost. So this is the business as usual. So if the cost is here, these are the operational costs. So with changes in operational procedures, including some tuning of your control loops, the cost can come down till this level. So this is popularly known as the box and whisker curve. So there's a wide range. So it can come down to a very low level with only altering your operational procedures. We have seen that even we have demonstrated some of these things during the test runs. After that, again, you need some changes in control and instrumentation, like replacing the whole thing, modernizing your control and instrumentations, putting some automation, like automatic start of mills and other things. Those solutions also I'll show you in my subsequent slides. Then last is your digital like fleet-wide monitoring. Typically, if you have say 3 units or 4 units in a stage, and you get a schedule stage-wise. So with optimization of the fleet, you can reduce your cost damages by selecting one unit and again increasing the load on other unit. So here also, the NTPC, they have a center called Antariksh, where they try to optimize their fleet. And last is your mechanical retrofit. So this is the last resort in some of the units where you simply cannot do with these things, and mechanical retrofits may be necessary. Like somewhere you need to replace your burners. all old burners, and without these burners, you cannot achieve minimum load. So, and as you go from here to here, your investment cost increases. You need a one-time investment cost to put in all those things. See, now you need to decide for your unit what value you can provide best, what would be best for the power system, and what would be the best in terms of value to the generator. So we had done some analysis in CA. So based on the this regulated tariff criteria, we had selected some units depending on three, four criteria on ECR, energy charges, then your GCV of coal. Because see, if GCV is very poor, you cannot go to lower load. We have selected as 2800. So you want it or not, you have to run these units on base load. Or the unit will be in shutdown, or maybe you may be required to say retire those units. So these are the criteria, and you need to decide where you stand. In fact, we have selected units, and we have the data for each and every unit in the country. Which mode and which value of flexibilization can be best provided for that unit. So now coming to the test procedures. I think. So the test procedures, the objectives was to check the ramp rate, ramp up, ramp down, what was the old and what was the new. Everything was done very gradually in very small steps. Initially, when we started, we did in very small steps, 5-10 megawatt. Then we waited for the parameters to normalize. And after stabilization, we moved to the next level. Then the other objective was to see what is the minimum load possible for that unit on a standstill alone basis, and then what can be the minimum load with retrofit, with tuning of control loops, and then with some other interventions. Again, we try to identify the process limitations, both thermal, mechanical, and different even C&I systems. Check what is the effect of aging, many of the actuators and other things, what are their response. Then we evaluated the operational practices of the unit, the existing, and how we can change that. And then identification of retrofits for those plants. What is required, what is mandatory if they want to run the unit on a sustained low load operation. Somebody in the questions, some participant had asked me that minimum load operation, 40%, how long can we run the unit on 40%? The answer is it's on a sustained basis. Minimum load is a sustained operation for as long as you want, without oil support and without any cost other than efficiency. Efficiency loss will always be there if you go down to a lower load. But you save yourself from equipment damage. And even efficiency loss also can be optimized, because part load efficiency would be a very important factor for low load operation. Our testing approach, as I told you, it's a very gradual approach. And everywhere we defined the mode, what is to be done next. And we tried to put everything on auto and operate everything on auto. But many of the things were not in auto. Auto operation was not available. For example, burner tilt. It's a very important parameter which influences the boiler, like reheat temperature and other things. So we put some of these things in manual mode and then try to operate it and establish that if it is to be in auto, what needs to be done. Then there were requirements of implementation of supplementary logics in the DCS that we did in between. This whole test run process took us around 3 days. And Moda, it was on 2 different occasions. We did it once, and after 1 or 2 months, we repeated that in the other unit. Then we made some changes in the set point of the control loops. Like before we started to raise the load or during ramp test, we reduce the, say, MS temperature set point so that it doesn't overshoot. Another thing was revising the sliding pressure curves and the PA flow curves. They should be done after carrying out the test runs, because while going to a lower load, we found a lot of problems like Economizer steaming and other things. So these are the expected issues that can happen and whenever you carry out a test run. This is a general thing. You can do it based on the procedure. You can carry out test runs on your respective units. So combustion is a very common thing, and what needs to be done, I'll tell you in my subsequent slides. Drum level control, that is also very important. And there can be problems with TDBAP. Typically, TDBAP recirculation valves in many of the units, it's on-off type, either full open or full close. That had been done to reduce the passing and other problem for the reasons of efficiency. But now we are replacing all those with inching type, control valve type. Hot reheat steam temperature. Everywhere we carried out the test run, we found there was overshoot of HRH and MS temperatures. Flame scanners. Then there can be stalling in PA fans. So when you reduce your load, you don't take flow from the PA fan and still maintain the pressure in the PA fan. There can be incidents of stalling, and it can be very severe. We have seen situations of stalling where the whole blades have been damaged, the roof was broken, the fans, they just collided with the roof, the flange blades, and they come out of the roof. Again, while reducing the loading of the coal pipes, there can be chances of choking in the coal pipes because of reduction in the fuel air velocity. Flue gas exit temperature, this is also important. If it is reduced below acid dew point, this is to be seen, because this is very important. There has been incidents where the whole ESP has collapsed. In Europe, there's one station, I have the pictures of that, where the plant was operating on a continuous basis on low exit temperature. And in the long run, the ESP got damaged and everything collapsed. All the ESP internals and everything just came down. Turbine vibrations is another problem, but turbine vibration, it's more of a symptom rather than the problem. Problem can be somewhere else, fluttering of blades or say problem in the bearing. Seal air can be another problem, like seal steam. When you reduce the load to a very low level, there can be issues with your leak steam and seal steam system. So you need to take care of these things also. So this is the description in the units. It was a common BHL make unit. What you need to see here is the coal quality. So the tested, because people talk a lot about the coal quality, because Indian coal is poor, and people often say that with this coal it's not possible. People just give the judgment that no, 40% is simply not possible. But I'll show you that we carried out the test runs in 2 of these stations. The coal GCV was in the range of 2700 to 3930. There was wide variation. On an average, it was 3000, even at 3200. So typically at Ukai, when we did the low load test run, the coal quality was around 3000. VM, volatile material, was in the range of 19 to 22, and ash 40 to 47. This is nothing new for the Indian coal. So other things, it's just the turbine design. So these are the field tests that we did. From 500 megawatt to 198 megawatt, load reduction, and back with certain hold points. We waited there with hold points. We waited for at least 2 hours. We took the readings and then observed what can be optimized, what are the process limitations. Then in UKAI, the whole data was connected to the BHL back office. BHL means EDN Bangalore. So they were also analyzing at the back end. The design team was there. So in different steps, so from 500 to 360 megawatt, there were 5 mills. 360 megawatt to 300, 4 mills. And then last, when we reduced to from 275 to 198 megawatt, there were only 3 mills, CDE. And the stations were very reluctant in reducing the mills from 4 to 3. And this is one of the most important things that you need to note. I'll also be explaining in the subsequent slides also the importance of this, because if you're afraid that what happens if mill trips, what happens if something happens, some foreign material comes in. But you need to understand that you are only increasing the probability of your unit tripping. With 3 mills, we have seen that the scanner improved. And there was a significant improvement in the scanners just by improving the turndown of the mills. So for the mills also, what we tested, what is the minimum loading on a mill? We call it as a turndown of mills. So we concluded that it shouldn't be reduced below 50%. Ideally, you can go till 40% also, but we recommend that it shouldn't go below 50%. And if any mill is required to be reduced below 50%, you increase the loading on the other mills and then withdraw that mill. And you'll see the improvement in your scanners. Then review of the sliding pressure curve and the PF flow curve. This also BHL in UKAI, they were reviewing it, and a report from BHL is still awaited. But other places, what we did during the test run, we increased the sliding pressure set point by 5 kg. Because at 40%, we observed that there was steaming and DNB in the economizers. So we increased this set point of the sliding pressure. And then BHL also carried out unit assessment with HP heaters bypass. So because that can be a solution which they can develop later on. The other test was ramp rate. This was done for 1 and 3%. This was done for different load ranges. And there's a lot of confusion in the air about ramp rate. Even somebody had asked me in the question that what is the maximum ramp rate that can be achieved. See, I'll tell you that you must target to achieve at least the design ramp rate, because that is the commitment you have got from your OEM, and the machine must be able to operate that ramp rate. However, ramp rate should always be defined in a load range, because see, ramp rate at 40%, from 40% to 60% load won't be the same as from 80% to 100%. So there's a lot of confusion. I can see even the grid operators, they are confused, and there's a regulation on the ramp rate, which a very generalized sort of thing. These things have not been considered in that. So I've been telling, I think Mr. Banerjee would agree on that. Even Mr. Gandhi, you need to take up these things with the regulators for defining the ramp rate in terms of load range. Because in Mauda at 3% ramp rate at lower load, the actual ramp rate was lower than that. Then we had seen that there was a difference in CMC response and the actual ramp rate achieved at lower load. There was unacceptable deviations in parameters. But now we know what is to be done. See, there are some other problems in the machines, so you need to set it right. Like passing of your superheater spray, preheater spray, you are not keeping burner tilts on auto. Because this is the practice which has evolved from base load. People, they keep the burner tilt on fixed and do other things. But now it's high time that you need to keep your burner tilt in auto and see the operator, because burner tilt auto operation was not available. Somewhere we are not allowed to test that, but you can test it yourself. So whenever you plan to shut down a unit, when it's a planned shutdown, carry out these test runs with the burner tilt and see the improvement, because we have enough data to support this. Even from the global operations and other things, we have data. Then as a conclusion, when you want to sustain these ramp rates and your minimum load, you need to upgrade your C&I system. See, these test runs was done in a, in fact, they were all done in a controlled environment in the presence of OEM, and there were a lot of people there. So, but in the normal circumstances, it won't be a controlled sort of thing. It will be done only by the 2 or 3 operators who are there. So you need to upgrade your C&I system, and you need to modify your operational procedures. So some of the issues, I think I discussed many of these issues. So there was, when we were reducing the load, some of the things happened. Like one was the wind box pressure collapsed. We had seen this in Moda also. We had seen this in Ukai also. One reason is you don't have a measurement for your individual secondary flow through individual burner. That if you're able to incorporate, it would be a very good thing for the control. And then unless you have a measurement, you won't be able to optimize things. So what we did is we closed the secondary air, even the primary air of the mills which were not in service. We reduced it, because for the burners, you need to keep some airflow at least for the burner cooling. So by reducing these dampers and the unwanted flow, we're able to improve the wind box pressure. And we could see the improvement in the flame also. Then there was high superheater spray, reheater spray. One reason was that the reheater burner tilt was not in auto. Then there was a passing in the reheater and the superheater both in one station. Feed water, when there was a changeover at lower load, we could see a jerky operation because the recirculation valves were of on-off type. And another thing, we carried out dirty airflow test in Ukai also, and Moda also. So there was imbalance in the coal pipe at lower load. So for this also, there are a lot of solutions available. There are solutions of variable orifices which can be put on auto and hooked into your control system. So because when you do settings of your orifice, you do at a base load. You put on a stable load and then you set your orifice. But with the changes in the airflow in the mills, change in the loading with unit load, all these things get changed, and there's an imbalance in the airflow across the coal pipes. So now coming to the key takeaways from the field test. First thing is the combustion optimization. So what you need to understand is you should target so that your combustion gets completed below somewhere here, just above the burner. Otherwise, it will continue here, and then the temperature, furnace exit gas temperature will be very high, and whole of your heat transfer will get distorted. So first thing what we observed was the improvement of mill turndown. So this is a brief guideline for taking the mills in service, the number of mills that you require to keep in service with your loading. So for 40%, we had kept 3 mills here. And I think this was the minimum. And if you are required to go below that, we are not targeting anything below 40% as of now, but we kept it here. And with better coal quality, we could have even targeted for 2 mills. 4 mills for this load range. Again, 5 mills at say full load. And this would be the typical ramp rate that will be getting at different load. Here the ramp rate is lower because if you keep a high ramp rate, there may be problem of overshooting. So this is not a rocket science. This is for regular operation. All these things you need to take care, and all of you are aware of these things. So before we proceed to the what are the solutions provided for the test run, you need to understand the combustion. See, first thing is for fuel air ratio, you need to comply the Nfpa guidelines. The Nfpa 8502 requires that the airflow is maintained at or above the purge rate, which is not less than 25% of the full load mass airflow. This is very important for the safety. And this holds good for even your mills, individual mills. So even in the individual mills, the air fuel ratio you need to maintain. Otherwise, you'll have problems like mill explosion. And for the furnace, this is, all of you know that, but you need to remember this and need to follow this even more when you go to a lower load. Never add any air in a dark smoky furnace. So this is very critical. Air fuel ratio is very critical for the safety of the boiler. And all these things will be in auto because manual operation is very difficult and it is not recommended. So we have solutions. In fact, NTPC is implementing some of these solutions. How to put, like with mill scheduler, how to optimize these things. Then coal mill air inlet and outlet temperature. This is very, very critical. You need to maintain, there's a guideline which is provided in different literature. So temperature range of 70 to 90 or even more. And this is with respect to your VM. Another important factor is your moisture in the coal. For that also there is a guideline with the moisture, what should be your mill temperature. So mill inlet temperature must be raised if your moisture is higher. For that also there is a specific guideline. What is the safe and what is the maximum inlet temperature that you can allow, what is the minimum inlet temperature that you can allow. All those things are there, and we'll share all those details with you. All those documents will be available because they're included in the operational procedures, which will be a public document, which will be released very soon. Primary air head-up pressure. This also needs to be optimized. Wind box pressure, which I explained, this needs to be optimized because this will control the combustion. Coal fineness and other things, they already taken care of. Burner tilt, I'd explained to you. And see, for your primary air header pressure and your coal flow, this is very important from the perspective of what is the minimum velocity in the coal pipe. If the velocity is low, then there can be, say, backfires. There can be accumulation in the coal pipe. If it is more, they can just push off the flames away from the burner. So it needs to be in a optimum this thing. It is 20 meters. That value also will share with you in details. So some key takeaway from the field test is sliding pressure that needs to be modified. BFP recirculation valve, this needs to be replaced. Again, measurement of excess O2, this is very important. Many times you have leakages from different places. So O2 measurement, say typically during the test procedures, the O2 was kept at around 5 to 6%. But somewhere you can go wrong. So it is always a good idea to validate this with a CO measurement, because CO is unaffected by air in leakages. So both these two together should be considered for review of the level of excess air that you have. Another important thing is why we were reviewing this response of the C&I system at low load. So typically in the original specs, engineering specs when the plants were installed, they aimed at automatic operation in the load range of 60 to 100%. So they operate very fine in this load range. Control is very good in this thing. But when you reduce this, they all fail. One reason is because many of your actuators, they don't have margins left. So the response at lower load is very poor. And sometimes it's very sluggish. You need to replace some of those actuators also to give a better response at lower load ranges. So C&I system is one of the most important things apart from the operational procedures. Fine tuning of CMC, logics, MS, reheater, flue gas temperature control. Then unit control with automatic mill operation, mill scheduler. You can learn from NTPC, they are implementing these things. Siemens had done the test run in Dadri, and I think it was in late 2017, and now it is being implemented there. So that experiences of NTPC will be a very valuable input for the rest of the entire sector, I should say. Then boiler lifetime monitoring, this is also very important. See, tomorrow you'll be operating in the market. You know, the reasons why I started my presentation with those slides is to make you understand that you are operating in a market where you don't have much of a choice. You are forced to operate that way. So you have very limited choices, either to operate, stay relevant, or to shut down. And if you are forced to operate, you're not going to lose money. And if you don't prepare yourself, you'll be out of business very soon, because your O&M cost will increase manifold. You may not be able to recover that money from the market. Another thing is the real-time energy market, although it has been postponed till June, but that is also coming in. So that will also make a lot of changes. So you need to know what are the damages happening in your machine by a particular mode of operation. Even that day I was attending a webinar on the real-time energy market. So one thing I found it very, very strange is the price discovery. I was told that they'll get signal from the market, but I doubt who will give you that signal, because the generator, if they don't know their own cost of production, who will give you a signal of the price? Somebody will give you a wrong signal, then you'll maybe at a loss. And if you don't know your cost, you may quote a very high price and you may lead to not getting scheduled, or not getting dispatched. If you quote a lower price, then you may lose from your pocket. So there are solutions which tell you online lifetime monitoring, online cost. So one such thing I've seen, I think Mr. Nikhil is there. He had made number of presentations on different forums, including NTPC O&M conferences, even on our USAID conferences, is the CostCom. This is a good solution, and I think you'll need it. This would be, although in our recommendations, even in the recommendations of Dadri, lifetime monitoring has been given as optional, but I considered it as a mandatory if you have to operate in a market. There are other solutions also. EPRI also has some solutions, PADO, but it hasn't worked the way, we haven't seen it working that way. I think many of these are yet to be tested. Then automatic plant startup. There's also a guide which will guide the operator. You have it for the turbine, like one button start ATRS rolling is there. It will tell you all the stresses and everything, how to proceed. But for boiler or for the entire unit, you don't have anything like that. So there are solutions for the entire unit, and you must try to get that. Modified procedures, we have prepared modified procedures and we'll be sharing it very soon. For the layup also, all these stations, they are having these procedures, but they have to follow it. Another solution that was given by recommendations by Intertech was nitrogen blanketing, because your oxygen damage has a lot of cost implications in the long run. Modification of PA, SCAF. SCAF also is not being used by many of the stations, I should say. And in the end, you are causing damages to the air filters. Again, you are delaying your startup. Even at lower load, your temperature gets below the acid dew point. And mill inlet, because see, if you have SCAF, if you have proper temperature, you can start the mill early. If you start the mill early, you'll get right temperatures. And then if you have the right temperature, the temperature transients will be lower. Even the damages will be lower. So don't ignore this SCAF, because there are a lot of units which had SCAFs installed but never used it. But now it's mandatory, you have to use it. Because in the recommendations that we have made to MODA and other stations, we have put it in the category of mandatory. Then another very good suggestion, again, that was given by Intertech was modification for hot filling of boiler from a running unit. If you have 2-3 units in a station, then you can connect a very small line. It's not a very costly sort of thing. And you can fill the drum of the unit which is to be started with a hot water from the running unit. And that will save the unit from a lot of damages. That will even improve the startup time. Some of these best practices which you have seen is some has been installed in India. Condensate throttling is one at NTPC Dadri. Then we have advanced process control, which is implemented at Simhadri, and it is in testing. Then there's another solution, plasma ignition system by GE. This, as per the claim, this can burn any category of coal, and you can reduce the minimum load of your unit by even 10%. Then these are some other solutions. From GE also we have digital boiler plus low load advisor, which is a host of things, will be connected to the entire unit and will guide you through the process. In Europe, in some stations, they are using the exploiting the storage capability of mill by adjusting the roller weight on the rollers. So in a short of period of time, they adjust the output from the mills. Okay, this is the last concluding slide. In fact, it's not a conclusion, because things can never be concluded in flexibilization. It's a going process. So for supporting 175 gigawatt of renewable integration, coal units are required to run on increased cycling mode. This is well acceptable, and there's no doubt about it. So units will be required to identify the best value they can provide to the power system. So each one of you need to identify what is best for the unit, what is the best value that you can deliver at the lowest cost. And there is no one fit for all solutions for flexibilization. Every unit is different. That is why we need the test run. See, ideally, you would need a test run for every unit to decide the limitation of that unit, what are the specific intervention for that unit. However, you can implement the test run of one unit on other similar units of similar make, similar vintage, similar, say, historical operation, like one BHL unit of say Dadri, or say Moda one unit. The other is also very similar, although we did testing in both the units, but they were not exactly true copies. There were some deviations, but the solutions can be copied. So and last, operational procedures is very important, and we have prepared detailed operational procedures from GTG, which will be making a public document very soon. That's all. And any question?
Thank you, Mr. Sinha. That was really informative. I think I still see about 222 people online at this time, and I think this is really, really great. And obviously, it seems to be a really informative session. That's why we see a lot of people on. I think before we go into the Q&A session, I think if Mr. Banerjee is on from NTPC, we would like to certainly hear him speak and the experience, that much needed experience that NTPC can share with the rest of the country.
Yes.
So Mr. Banerjee, if you can please.
Yeah. Thank you so much, Mr. Anuj. Am I audible?
You are audible, sir.
Yes, you
Okay.
are.
Yes.
And thank you so much, USAID, for organizing such a informative and nice webinar. In fact, it is an eye-opener to many of us. And in fact, the points Mr. Gandhi had raised and Mr. Anjan Sinha had raised, these are the very relevant points we are facing nowadays. And we have also undertaken the pilot study in 2 to 3 cases in our Mauda units, in Dadri units, at Vindhyachal units, and at the end of the pilot, we also come out with the same observations whatever we have gained in Gujarat, Mr. Gandhi. The temperature aberrations, steam temperatures, the metal temperatures, the drum level fluctuations. These are the key issues which are to be addressed basically. So this pilot study successful does not mean it ends here itself. It is a start basically. Now from now onwards, we have to take multiple initiatives together so that we can run the units at higher ramp rate, at minimum load, without any major variations or aberrations of important parameters. So that is our objective. Then only at the end we can tell that we are successfully running at minimum load of 40%. So it is a misnomer sometimes that we can run the units at 40% with the present conditions. No, it is not so. Maybe we are running for 2 to 3 hours without any major deviations, but we cannot run it for hours together, for days together. So to make it happen, we have to take multiple initiatives. And the initiatives, Mr. Sinha had told so many initiatives in different packages and suggested by different agencies worldwide. They are popular. In fact, we are going forward with some of the initiatives in 2 of our units presently, one at Dadri and another is at Shimadri. The objective basically to have higher ramp rates and minimum load. Now, coming to Mr. Sinha's observations of frequent fluctuations of schedules nowadays, we also observe in our plants, in many of our plants are subjected to fluctuations of scheduling. Scheduling fluctuations are not only attributable to SCAD alone, but also it is because of ancillary services and of course the beneficiary schedule variations. So it is a combination of all the factors, and it will be further intensified when RTM will come into the picture. So this will remain as it is, I think, and there is no ready-made solutions to all of us in our power fraternity. In fact, it is a worldwide scenario, this type of fluctuations, but number of fluctuations, the frequency, the deep fluctuations, that can be eliminated to some extent. We can think out this power fraternity as power generators. We can think together how we can minimize that. One suggestion could be that when the beneficiary schedule part is fluctuating, we'll abide by it, because we can presume that beneficiary is giving us fluctuating schedule because of the requirement of the grid. But when it comes to SCAD operations, which is basically for merit order balancing, where this ramping may not be so much of requirement. So we have to balance it. 20, 30 times in a day fluctuations, and sometimes it is seen that fluctuation is two ways simultaneously. Simultaneous blocks are plus 75, minus 75, like that for a 500 megawatt units. This type of fluctuation will damage the equipments and the units in the long run, definitely. So we have to have a balanced approach. So one solution could be that balancing approach can be the ACD operations with a without having any higher ramp rate. That ramp rate may be 0.5, 0.6, whatever it was there before, and other beneficiary fluctuations we can manage, in fact, with the higher ramp rate, say for 1%. And coming to our observations on that particular day, 9 p.m. In fact, Sinha ji, you like to know that our central GS stations had contributed, particularly coal-based stations had contributed immensely with respect to primary frequency response, and all of our units almost performed exceedingly well on that day. And though power grid had managed it well with other means, say hydel and gas, and with some support of coal, of course. And our performance was not that bad on that day even. So that is one point I would like to raise. And coming to 40% minimum load, that I want to elaborate here to the audience, that in two-prong approach we are taking, one at Simadri, where we mainly concentrated on the control logic optimization, advanced process control, where these logic loops are acting on a reactive basis. That means when the temperature goes high, then only it suppresses with spray. But the advanced process control is basically a smart control. That means even before that happens, they can act. That is basically proactive means of control. So we think that with that approach, we can be much faster with a minimum deviations that we have to see at Simadri. In fact, it is under demonstrations and under tuning at present. Maybe within 2 to 3 months it will be implemented. And at Dadri, whatever solutions Sinha sir had explained, some of the solutions we are adopting there. For example, flue gas temperature control that is to be done through SCAF auto operations. For example, wind box DP going low at lower load can be operated with a single FD operations. Instead of 2 FD, if we operate at single FD with higher pressure, we can maintain better wind box DP. So similarly, the recirculation valves are regulating type, we are replacing it, and mill scheduler. So all those stuff are being implemented at Dadri, and so two different approaches we are taking. And in fact, at the end, after implementation in both Dadri and Simadri, we can able to tell what are the real solutions required to maintain 40% minimum load for hours together, and higher ramp rate, of course. And at the same time, we are moving ahead with some more fleets of higher dimensions, 500 megawatt fleets, which can have this type of facilities available in future in stage 2. So we'll think for that, and then gradually we'll proceed further. So that is the way we will approach. And it is really, thank you so much, Monali Madam in particular, for organizing such a beautiful seminar in the night time, and we can discuss some of the questions which is appearing in the screen, so we can discuss. So Mr. Sinha, and we can take questions from the audience. Over to Mr. Anjan Sinha.
Thank you, Mr. Banerjee. This was really helpful, and I think it's 8:30, and we won't want to hold everybody back at night at this time, but we'll still take few questions. And I'll invite Mr. Anuj Vashish, the pilot manager, to actually go ahead with the questions, and maybe we can have few of them answered by Mr. Sinha and other panelists.
Right. Thanks, Ripu. Thank you, Banerjee, sir. We, I think, have a host of questions lined down on the from the panel, from the attendees. And given the paucity of time, we will be taking at least 5 to 6 questions, maybe a little more. So, sir, the one of the first questions that that we have is, how do we ensure reliability of plant operations during flexible operations, and the impending failures during cyclic operations, and detect them before?
Do I still need to answer this, or you got the answer in the presentation?
Your call, sir.
No, I can still answer.
If you think we have answered, then we can go to the next question.
We can add to it.
Yeah.
We can add to it.
Yeah.
That in Dadri, we are installing software related to boiler fatigue monitoring system. So once it is done, then at least one component, the thick wall components, which are subjected to creep and fatigue because of the fluctuating load, that can be taken care of. At least we can understand how the life consumption would be with the higher ramp rate and minimum loads. So one approach, it will be a multiple approach. One approach may be this: the blade vibration monitoring. That is another LP turbine high vibrations monitoring, and the blade itself. That can be another. So there may be multiple way we can enhance our reliability with respect to flexibilization.
Right. Thank you, Banerjee, sir. The next question is, what would is the impact on the per unit cost for every 1% decrease in PLF? I think, Sinha sir, this is for you.
So, per unit?
Per unit, what is the impact on per unit cost for every 1% decrease in PLF?
This has to be calculated. I won't be able to provide you right now with that. Would be on a percentage that will depend on the level of load. It won't be a straight line, first of all. Say from 100 to 80, there may not be any decrease other than if you're talking about a fixed, I'm not talking about the fixed cost, only about the variable cost. Fixed cost, it's easy because you have the annual fixed charges and then the number of units delivered, you calculate based on that.
Right.
For the variable cost, one cost would be your loss of efficiency, and other cost would be the events like number of load following, your damages, and other things.
Right.
So that can be calculated based on the load range.
Okay, sir.
So if you want specific answer, I will send it.
Right. So in any case, we will be sending replies to all the questions. So the next question, and this is an interesting one: what action should be taken to avoid PA fan from stalling at low load?
Yeah. Say,
we do have Nikhil also. If Nikhil, you want to jump in, I mean, please feel free to.
Yeah.
You can add his this thing. Maybe it's early morning. Yeah, Mr.
Yeah,
Nikhil.
but he has been answering the calls through chat, so I mean he can be free to answer here as well.
Okay. Anyway, see, one is the review of the PA flow curve. See, ideally, PA flow curve till 50%, there must be some fixed. When there was a study done by NG, I think Mr. Banerjee is aware of that. The PA flow curve at Dadri and Farakka, they are a straight line linear curve. And what they have suggested that till 50% it will be a straight, after that it will be a linear. So in the linear curve, sometimes it is lower than the flow is lower than the stalling limit. So for that, there's one is the modification in the PA flow curve. Other thing is to maintain the proper airflow and the pressure. And again, you have to make a change in your controls. Because people typically keep fixed pressure on the PF. It's for a base load, but for lower load, that pressure limit also has to be changed as per the curve. So if PF flow is in auto, then it will take care of by itself. Otherwise, if you are doing it manually, then you have to adjust that pressure.
Right.
So I'd shown you in the presentation that modification of PA flow curve, that is one of the requirement.
Right. Sir, I have a question for Mr. Gandhi from GSECL. And the question is, what is the practice of soot blowing at GSECL? And at what minimum loads are they doing it? Gandhi sir, over to you.
Yes,
more than 75% mega of load.
Yeah.
Below that, actually, still we are not practicing it.
Sorry, sir, I think.
Yeah, I'll share with you on soot blowing, Anuj, a very interesting thing. I won't name the station. There was a explosion in the bottom ash at the time of soot blowing. A very recent, all the photographs. What happened during minimum load, they started operating the soot blowers. And that time only there were very big sized clinkers. They fell down and there was puffing in the furnace, and that time the bottom mass exploded. So ideally, before reducing the load, you carry out all your soot blowing activities, and then you have to optimize at lower load. Because see, if your combustion is not proper, if there is clinkering, if the clinker size is bigger, because if the temperature gets altered, the clinker size will increase. Lot of factors. So that is a very important question. In fact, for soot blowing also, there's a detailed procedure also, and in our operational procedure document also we have included that.
Right. So there's the another question is whether this type of minimum load tests are possible with CFBC boilers and biomass co-firing.
See, CFBC I can answer because I have worked in CFBC boiler for 2 years myself. The most suitable for low load operation are the CFBC boilers.
Right.
That is for sure. There won't be issues because a lot of this combustion, coal five, coal mill, these things are simply not there. You feed small particle size, not pulverized coal, but small sized coal that goes there, and that will be circulated many times. You need to maintain the bed ash. Only thing is the boiler pressure and the bed ash temperature. If that is maintained, so you can very comfortably operate it on 30%. For biomass, we haven't yet tried because Dadri is firing, but yes, biomass, we have seen from global experiences, they are operating it. But India, we don't have experience on that. Maybe at a later stage, we'll have to see. A lot of things we still need to look into, but like supercritical, we don't have a lot of experience here. Biomass also, we need to have some experience on low load with biomass. Okay.
Right, sir. And sir, the next question is there any significance of fuel air damper with flame?
Fuel air damper?
Is there any significance of having fuel air damper with flame? So I presume the question is that whether fuel air dampers plays a vital role in controlling the low load test runs.
Fuel air damper, yes, fuel air damper. See, instead of that, many stations, many places, they are having orifice for controlling the coal flow. Fuel air damper means, you mean, I think, from mill to furnace.
Yeah.
Am I correct?
Yes.
So that is already there in many of the stations, but I think it is on-off type. It's not modulated. The modulation part and all, it is done by the orifices, and mostly the orifices are of a fixed type. But in one place, we are thinking of trying with a variable orifice. In NTPC, Mr. Banerjee can reply. In many of the stations, they are going to install, or there is already installed this flexible orifice supplied by BMWI with BHL.
not yet, but we are proposing one sort of thing at Uchahar units because of the multiple, many of the unit tripping because of flame failure at Uchahar.
Yes, yes.
And maybe in future days it will be required.
Yes.
Right, sir. In
And
fact,
Okay. Okay.
sir, in fact, the next question is regarding that only. So the question is whether auto variable orifices in coal pipes is operational in any of these stations, be it NTPC or GSCCL.
So I haven't seen any, but I know the supplier, the producer. In fact, he holds the patent. We had a meeting also through VC only during this COVID period. So he named some of the NTPC stations where they are going to supply. They have some arrangement with BHEL. But elsewhere, I know cases where it is working in Europe and other places.
Right.
Because if we analyze the dirty airflow test results, we find that there's a lot of imbalance in the coal pipes. And one station, you remember, Anuj, you also with me. This is the reason we were seeing the burners. I just saw the data. Then I went straight into the boiler and then showed them that, see, these are the burners. The four corners, one burner was totally eroded, one burner was totally choked with clinker. So this is the type of flow they were having inside the boiler. And then you can imagine the quality of flame they must be having. And that was precisely the reason they were not able to come down below 70%. Even at 70% load, flame was not stable.
Right. So I think, sorry. So I think we have one more question that we can take given the time that we have left. The question is regarding soot blowing again. There is a practice of having 3-tier soot blowing in 500 megawatt units. What other practices can be done to prevent clinker formation?
See, in fact, there's a separate presentation on fouling and slagging in the boiler. I can take it sometimes else. It's not a very simple thing. 2 or 3 things. You need to analyze your ash characteristics in your coal, clinkering characteristics. Then what is the fusion temperature of the ash? So your temperature, your furnace exit temperature must be below the ash fusion temperature. There's one thumb rule. There are a lot of other factors, but it's not only one simple thing. So different characteristics of the coal you need to take care, and then you need to maintain your combustion properly, airflow properly. This is for the clinkers. Again, ash deposition in other places, there can be different reasons, fouling in different parts.
Right.
Again, with these changes, this parameter changes with the moisture content. All these things, parameters is not a very fixed sort of thing. Different characteristics, different impurities in the coal, they can change even the fusion temperature of the ash. Again, moisture in the coal is also very important. So in that case, if you say dry the coal, typically some stations, I haven't seen in India, but they use a coal dryer before feeding it into the mill, where there are very high say moisture content in the coal. They have somewhere around 18 to 20% of moisture. In India also, during the rainy season in the eastern region, I have seen very high moisture content.
Right. Thank you, sir. I think we would be able to take only those questions in this webinar. We have noted down all the other questions that have been shared by the participants, and we will certainly reply to them.
One part. One question. Question to Mr. Sinha.
Yes.
Okay. Sinha ji, some questions are posted here. I just go through it. One interesting question.
Yes.
When RTM will set in, what will be the future of coal-based power plants whose ECR is more than 3 rupees?
Okay, very good question. See, I'll tell you a background of this, why it is good. So I've been in NTPC. So whenever things like if there were any regulatory changes or any such thing in NTPC, people used to say that they used to cry foul and then make a lot of noise. But every time we gained. One example was DSM, because everything is there. Say it's a market, and the market you need to learn the tricks of the trade. So if it is more than 3 rupees, there are other services which will be priced accordingly. The value of power will not be fixed in the future. And real time, there will be something called scarcity pricing. A lot of things will come in, just wait and see. But first thing is, need to know the actual cost of your production at different levels. Like if you are to operate your unit, say at 40% or say 50% load, and then you have to deliver that power. There's a cost of power, different cost. And it's very high because those numbers are added in a different, this thing, like typically if you have your ECR is 2 rupees, then that there can be an additional cost of say 1 rupee, 20 paisa. Just an example, it can vary widely. So you must be aware of that. And then you need to know the opportunity cost. So market will pay for the scarcity pricing. So it throws a big opportunity for the coal operators who can operate flexibly. So all these non-pithead stations, low merit order stations, and more than that, this mid merit order stations, they need to prepare themselves for flexible operation, because a lot of opportunities are going to come. Anything, Mr. Banerjee, you would like to add?
Excellent answer, and I think it should be the way. But one thing for supercritical units, some of the supercritical units are located at non-pithead and having very high heat rate, very high efficiency. They are either in a stop conditions or operating at a part load. So we are not benefiting out of that, the supercritical efficiency. So in days to come, there should be some changes in the practices so that these units can run at least. So there should be simultaneous approach of stopping the old and inefficient units, and at the same time, state plants should operate at 55% load at least, so that there's some margin available for the flexing. And at the same time, these supercritical units with a hit rate of say 2100, things like that, that plant should run.
Yeah, that would be a very difficult thing, and especially this post-COVID sort of thing. I don't know. I'm still perplexed about this. What is going to happen in the near future? But one thing is for sure: many of the old plants, they will be retired now, because the demand will stay low for some time. In fact, we had visited some of the state plants after looking at their cost of coal and other things. They had huge O&M cost overruns. Then I advised them that, see, nothing you can do. It's better, your plants are very old also. So better to stop these plants, and if you can put in some solar or other things, go for that. Because you won't get, for example, plants in Punjab getting coal from very far off, and they're all old plants. So some of these will shut down, and then maybe the supercritical, they'll get opportunity to generate. Because
I think, sir, we'll have to stop here. It's already.
Yeah, one thing before I stop, all the questions to all the participants, will answer each and every question, and will send it to all the participants. Sort of a say FAQ type. So some of the questions may be common, and others may be say interested in knowing the common answers. So there will be a common FAQ sort of thing. We'll prepare it, and within a day or two, we'll send you along with the presentation.
Yeah.
Okay.
All right, thank you, sir. I think this is great. We still have about 160 people on, 170 including us. And there's a lot of interest, but we'll keep on engaging with the participant as you rightly mentioned. But at this time, I'd like to invite Tushar Sood, who is the Chief of Party from the USAID, leading the Great Renewable Integration and Sustainable Energy Initiative implemented by Deloitte. So over to you, Tushar.
Yeah, thanks, Ripu. Good evening, everyone, and thank you for your participation in the webinar today. Since we have already exceeded time, I'll try to keep it short. We had close to 240 participants today, and it's really heartening to see such an overwhelming response to the webinar in spite of the difficult times we are going through. Thank you all for making it a success. On behalf of GTG-RISE, I would like to extend my gratitude to Mr. Banerjee from NTPC and Mr. Gandhi from GSCCL for their active participation in the webinar today and also taking questions from the audience. In terms of, we also, so some of the team members who have supported us from both from NTPC and GSCCL who have joined today's webinar and have supported us throughout this study. I would also like to take this opportunity to thank them. We do look forward to their continuous support in future as well. And unfortunately, I understand Mr. Tiwari, Director Operations NTPC, could not join us today due to certain exigency, but his overall guidance and support has really provided us with the right forum to complete this study. Thank you, sir. In terms of the aim of today's webinar, it was to share our experiences and the lessons we have learned while conducting the multiple low-load test runs, and also to provoke discussions, initiate discussions. I think looking at the response we have received, we have been able to achieve that objective well. In terms of the next steps and what we are looking to, I'm sure the low-load test and ramping testing procedure documents which we have put in public domain today is well timed, specifically looking at the evolving situation in the Indian power sector, and will serve as a guiding tool for the generating stations in India as well as in other parts of the world, both in terms of planning and implementing the test runs for flexible operations, as well as in making their future roadmaps for this. I think this was the third webinar in the series on the coal plant flexible operations, which we have done. And we'll continue to build on the experience we have gained on this initiative. And we'll have a few more planned in the coming months. So please stay tuned on this. And then I would like to give special thanks to the USAID team, Michael and Monali, for their continuous support and guidance on this project, as well as on the specific initiatives we have been taking. So due to time constraint, I think we could not take all the live questions, but as Mr. Sinha said, we will make sure that we respond to all the feedback and queries which you have. So please do write into us and we'll make sure that we respond to all of them. With this, we can close this webinar. Thank you once again and have a good evening.
Thank you.
Thank you, everyone.
Thank you. Thank you.
Thanks, everyone. Good night.
Good night.
Okay, bye.
Yeah, bye. Thanks.
Bye.
Ripu, Paul, presentations, I'll send you the PDF. Okay.
Sure, sir.
I'll send.
Yeah, thank you so much, Sinha, for a great presentation. Banerjee sir, thank you so much. Great, both you and Mr. Gandhi really added a lot of perspective and live experiences really helped.
Thank you, madam. Thank you, madam. Thank you so much.
Thank you, madam. Thank you.
Thank you so much for joining us and giving us, 2 hours, quite a bit, and also the yesterday's time also. Thank you so much.
Thank you. Thank you.
Okay.